All right. Well, good afternoon to everyone joining us, and welcome to the Water Finance and Management webinar series. This is Andrew Farr. I'm the managing editor of Water Finance and Management. My pleasure to introduce our webinar today, Building an Intelligent Water System, sponsored by Sensus, a Xylem brand. So, as I mentioned, good afternoon if you're joining us from the East Coast, or good morning if you're on the West Coast, where a couple of our presenters are. So as I said, our topic today, building an intelligent water system. Obviously, if you work in the municipal water industry, you know that smart metering and specifically here talking about advanced metering infrastructure has really been a big consideration for water utilities over the last 5-10 years. That the technology has really advanced and can provide a number of benefits to utilities, both on the operational and financial side of things. So it's been interesting to see the development of the technology, and Sensus is one company that's certainly been at the forefront of leading a lot of this. So it's a pleasure to have them with us. Just a couple housekeeping items before we get started. We're going to launch a quick poll question right now. This is just to help us get an idea of who is online with us. So if you would just submit your answer, we would appreciate it, and then you can click that blue Return to Presentation button. So following our presentation, we're going to have a little bit of a Q&A session with the presenters. So as the presentation's going on, I encourage anyone that has any questions to submit those. You can do that by typing your questions into the question panel, which you should see on the left-hand side of your screen, and you can also maximize and minimize that viewing window. So as I mentioned, our presentation on building an intelligent water system, we are going to hear a case study example from the city of Walla, Washington, which recently completed deployment of a Sensus AMI system, and was really able to leverage some of the pressure monitoring and level monitoring benefits the system offers. We're going to be joined by 3 presenters. First, we are going to have Joseph Dreyer. Joe is a solution application engineer in the Sensus Water Marketing Group. In that role, he primarily focuses on working with utilities to reduce non-revenue water, leveraging Xylem solutions. And then a little bit later on, we are going to be joined by Adrian Suter, who is the Water Division Supervisor for the City of Walla. He is responsible for the city's water distribution system, metering, and multiple regulatory programs. He has over 20 years of experience working in municipal drinking water systems. And then finally, we are going to have Joe French, who is the AMI Administrator for the City of Walla. Joe has a civil engineering degree and his drafting and surveying certificates. So at this point, Joe, I will go ahead and turn it over to you. And so whenever you're ready, take it away.
All right, thank you. Hi, everyone. My name is Joe Dreyer, and I work as an application engineer in the Water Product Management Group at Sensus, a Xylem brand. And I'm delighted to be here today with Adrian and Joe from the city of Walla. Together, we're going to be telling you the story of how Walla turned their FlexNet AMI system into a smart utility network. We're going to give you some background on Walla and their water system. We'll discuss how they are monitoring and managing pressure in the distribution system. And we're going to review some examples of the insights and improvements that have come from all of that. Finally, we're going to talk about some other applications that the utility is pursuing, including creek level monitoring, remote shutoffs, and even more. It's my pleasure to turn it over to Adrian to tell you a little bit more about the water utility that he manages.
Thank you, Joe. For just a brief overview of our water system, the city of Walla, we have 2 water sources, including a watershed and deep wells. Our Mill Creek watershed is 36 square miles. It's our primary source of drinking water. It is diverted and piped about 14.5 miles from the watershed down to the water treatment plant. Our water treatment plant is a UV sterilization and then chlorine as a disinfection. Wells are a small portion of our water. We do have 7 wells. They are a full backup for our entire system, and we do have a ASR, Aquifer Storage and Recovery program, that we've stored about 10 years worth of water underground. Our water distribution system, the city is one of the oldest in Washington, established in 1862. Very old infrastructure. A lot of challenges that we face is managing this aging infrastructure. Our average steel mains are about 65 years old. We have a total of 191 miles of water main. 91 of those miles are at increased risk and age, need to be replaced. We do have a couple interconnects with a small utility to the southwest for emergencies. It goes both directions. We have 4 pressure zones, as you can see the shading. From the northeast to the southeast corner, we have an elevation drop. We have 29 PRV stations that regulate these pressure zones. One of the big challenges here in Walla Walla that we face is our non-revenue water. We produced about 3.4 billion gallons in 2014 with a water loss of 29.4%. It roughly is about 1 billion gallons of water lost annually. Leak detection efforts, we've used traditional. We've done 2 complete passes of the city with acoustic correlators. With our steel mains and our rocky soils, we have a very high noise. It carries a long ways in the steel mains, which takes a lot longer to pinpoint them, find them. They don't surface. They go through the alluvial gravels. So it's very challenging. We have considered some in-pipe inspection for our large mains, transmission lines, that we believe we're not getting good leak detection with acoustic hardware. So that might be coming up in the future to help us out. Capital investment initiatives, we have a great program. We call it the Infrastructure Repair and Replacement Program. We replace the water, the sewer, the storm lines, and the streets all in one pass. It's a good program. It's kind of the final resolve for getting our old aging infrastructure updated. Some of our metering solutions, I'm going to turn it over to Joe French. He's going to talk about where we went with.
Thanks, Adrian. We completed our AMI deployment in 2018. We can collect over-the-air readings at hourly resolution. For our residential meters, we use the Sensus iPearl, and for commercial and industrial, we use Sensus Omni meters. We have about 11,000 meters total in our system. Some of the advantages are the accurate readings. We've seen a decrease in apparent losses from under-registration with our the older aging meters that were replaced. In the wintertime, we eliminated read estimates from bad weather where the meters were inaccessible. And we're able to detect customer leaks to help conserve water. In 2017, we had a 75% reduction in leak forgiveness applications. And of course, there's the reduced carbon footprint from decreasing the truck rolls. So with the FlexNet, it's a really solid foundation. It's the backbone of our AMI system. It's the foundation for what we call a smart utility network. It's a high power level, low noise floor, and makes the system very reliable. We have 2 radio base stations that read all 11,000 meters. And you can see on the map that they're to the north and to the south. In red, we have 2 towers that cover the entire system. With 2 towers, it can read almost every meter independently. It makes it very reliable and redundant. I'm going to pass it back to Adrian now.
Thank you, Joe. So as you described that solid foundation, we really got to that stage with our system that it was very reliable. We had control of it. We were keeping it maintained, keeping it running. Everything was working right. So then that turned us to what problems can we solve beyond metering? We have this great FlexNet system to our advantage now, and Where do we go from there? So we started looking at some other applications. The first one that really came out was the pressure monitoring, pressure profile. Really exciting that we can see the system behavior. We can monitor asset health, detect breaks, and exercise a really solid pressure management with the data that comes in from this. Another application, hardware application that came with a meter was the remote shutoffs, bill payment failure. We've also looked at using this automated valve for a number of applications. One is we're looking at flushing dead-end lines remotely. Creek level monitoring, it's flood warning, level trending, really emergency kind of based, that we can get a warning that creek levels are rising prior to it actually breaching. So district metering, that's our pressure zones. When we're really looking to reduce our non-revenue water, we can hone in on a single zone versus an entire water system. Water quality, effluent temperatures, we've also deployed dissolved oxygen and pH sensors with this, so it's really broad system and wide applications that could be used. The really exciting part is the requirements. You know, it's battery powered. We can put now sensors, switches, controls pretty much anywhere we want. So that's really what opens up the possibilities and where these applications started taking off. I'm going to turn it back over to Joe Dreyer now to talk about some of the technology that we've used to apply these applications.
Thank you, Adrian. So this is Joe Dreyer again from Sensus, and I'd like to tell you about two products in particular that Walla is using for pressure monitoring, level monitoring, and some of the other applications that Adrian just described. So the first product I'm going to tell you about is the Ally meter. This is a new residential meter that has an integrated pressure sensor. It also has an integrated temperature sensor and a remote shutoff valve. So this allows you to monitor pressure deep within the distribution system where traditional solutions might not be able to reach. It is a convenient way to gain system visibility, and really it's just a meter swap out, which makes it a little bit easier on the installation side of things. The remote shutoff valve allows the utility to turn off a customer's water over the air, and that particular function has 3 states, including open, closed, and a reduced trickle flow. The Sensus Smart Gateway sensor interface is essentially a FlexNet radio that can power and read sensors. And so this is the second product that Walla really leveraged to power the new applications. It can interface with 2 4-to-20 current loop sensors. Those are the milliamp output sensors that are very common in the water industry. And in addition to that, 2 contact closures. It's battery powered, and it operates in the same network that they are using for metering. So the Smart Gateway is intrinsically safe, Class 1 Div 2 certification there, and it is rated for outdoor applications with the IP66 certification. The Smart Gateway does support different sample and transmit rates down to the 1-minute resolution. The battery life will vary depending on the sampling frequency, and it can range from a little bit over 1 year up to 12 years or more, depending on how often you're sampling. So you can actually change the sample rate over the air through the head-end system, and this allows utilities to collect higher resolution data for targeted periods of time if they wish. So for example, if you had 2 weeks and you wanted to collect 1-minute data for those 2 weeks, for instance, to feed into a hydraulic model, that's something you could do with this technology. So Walla has leveraged these 2 products to implement their near real-time pressure monitoring in the distribution system. And before we get into the details of how they accomplished this and some of the insights that came from it, I wanted to share with you a little bit of background on the importance of pressure monitoring and some of the benefits that can come from it. So why do we monitor pressure in the distribution system? So when we refer to pressure monitoring here, we're really talking about pressure sensors located throughout the whole distribution system, reporting data in near real time. So that could be hourly or even on a sub-hourly basis. And this type of pressure monitoring, it's an important factor in each of the pillars of leakage control that are published in the AWWA M36 manual. When it comes to the first pillar, pipeline and asset management, pressure monitoring allows you to detect changes in pressure. Utility is equipped to address the root cause of the behavior, which can help reduce fatigue stress on pipes. And this, in turn, can reduce the likelihood of events like bursts. When it comes to pressure management, pressure monitoring provides the utility with confidence in the full system pressure profile. The utility can understand how pressure varies across an area, a zone, or even over the course of a day. With pressure monitoring, you have a better gauge on the magnitude of opportunity for reduction. So in other words, how far above optimum levels current pressures actually are. And then finally, pressure management can be carried out with more confidence. So monitoring the pressure allows you to see the impact of the changes made, and it also helps the utility be sure that minimum levels are maintained so that you have safe, clean drinking water for your customers. Regarding the speed and quality of repairs, pressure monitoring allows the utility to be remotely informed on the health of assets that might have been previously unmonitored. So for example, a pressure-reducing valve station or a PRV. And we're actually going to review some examples of how Walla detected a malfunctioning PRV in their system and how they were able to mitigate it. Pressure monitoring allows you to detect and start mitigating issues on the scale of hours as opposed to waiting until, let's say, the next scheduled physical inspection of an asset. So for instance, some utilities only inspect their PRVs on a quarterly basis, whereas now Walla is able to see an issue within a matter of hours. And finally, I think one of the most important advantages is the lower cost point. When it comes to remote battery-powered sensors, it can really be a fraction of the cost compared to the traditional solutions that might require you to run power or have instrumentation panels. So the fourth pillar, leakage control, that's explained in the AWWA manual, is shown here in the graphic on this slide, and it describes three components of real losses. And so those are background leakage, unreported leakage, and reported leakage. And the thing to stress is that each of these have pressure stabilization and pressure reduction cited as a primary tool for mitigation. And at Sensus, we see pressure monitoring as the tool that helps a utility go about pressure stabilization and reduction. So when it came to designing a pressure monitoring plan for Walla, we had to take into account a few important factors. And the first one was the overall number of points available. This is oftentimes driven by costs. We also wanted to make sure that the highest and lowest elevations were captured in each zone. And that would provide a range in pressure, which would be including the maximum and minimum. Additionally, the hydraulic spacing, or in other words, the distance along pipes from one point to the next, was important, and we wanted to maximize it to get the best overall distribution. Since we were using an existing AMI network, the network strength was an important factor. But fortunately for Walla, they have a very robust network, and this wasn't a limiting factor. And then finally, we really wanted to be strategic in the location types. So we knew that we wanted to place about 20 alloy meters for the remote shutoff use case. That is, Walla had a list of accounts where they often have to go out and shut off the valve. And so we actually started with this as a base for pressure monitoring. And these are noted in the map that you see on the slide here. They are the red icons. We then added in the PRV locations since we knew we wanted to monitor these assets. Walla sees them as critical. And those are shown in the blue icons. And then finally, we filled in the remaining gaps with additional alloy meters, and those are noted as green icons. So that last part can be done manually, or you can actually use tools that can run an algorithm to suggest the best locations. So altogether, we had about 100 points, or 1% of the service connections. And going forward, Walla is going to be increasing the density of the sensors, and they're going to do that strategically. So they're going to look at areas that are prone to issues or require enhanced visibility. I'd like to turn it over to Joe French now to tell you a little bit more about the installations of these pressure sensors.
Thanks, Joe. So the first place we wanted to monitor pressures was at a PRV location. We wanted to measure upstream and downstream of a 16-inch PRV. The sensors we used have a 0 to 300 psi range, 0.5% accuracy, a 25-foot cable, and they're IP68 submersion rated, which made them perfect for installation in a PRV vault. The installation was pretty straightforward. We used existing pressure gauge taps. Not only are the PRV sites good locations to install pressure sensors, but installing one upstream and downstream gives us the ability to monitor that the PRVs are functioning properly. Another option for installation was just at a residence or at commercial and industrial meters. So the Ally meters that Joe mentioned earlier have internal pressure sensors, and Omni meters have pressure test ports that the pressure sensor can be installed into, as you can see in the picture on the right. So between the Ally meters or pressure transducers at PRVs or in Omni test ports, there are lots of existing facilities so you can easily deploy pressure sensors in your water system. I'm going to pass this back to Joe Dreyer.
Thanks, Joe. This is Joe Dreyer from Sensus again. And with all these devices installed, Walla needed a way to view all this pressure data in one place. And so for this, they turned to a new software application that we have at Sensus called the Pressure Profile. So this is a tool that is used for trending and analyzing pressure data in the distribution system. And in the slide above, you can actually see the initial design of the pressure monitoring plan, and then followed by, on the right, you see the view and pressure profile after the installation of the monitors. And so this allows the user to trend out data and set up and view alarms. The data can be displayed in a map-based view or a chart-based view, and you can also do some grouping of the installed devices. So the dashboard page is there when you first log in, and it shows some key information on the system, including the installed devices, any active alarms, and basically you can create widgets that you can customize. Grouping is useful for drilling down into the pressure data. So for instance, you can create a group that has multiple parent-child relationships, like Pressure Zone 4, Milton Neighborhood, 3rd Street PRV. And Walla used these to create groups for each of their pressure zones. Alarms can be configured on a device level, and they utilize a threshold that's set for high or low values. And these actually get pushed down to the installed devices, which means that as soon as they detect a reading that violates the threshold, they send up an alarm. And the alarms are based on a magnitude or a value, and then a duration. So for instance, 90 psi for 30 minutes. So the chart view allows you to see data over periods of time. So for instance, 7 days or 30 days. And you can also filter by a group or even by pressure values. And then finally, the map view allows you to create custom display ranges for the pressure, and that allows you to create a heat map of the system. And you can actually play the data over time to see how it changes. So with that description of the application, I'd like to turn it back over to Adrian to talk about another feature that we implemented with Walla, and that being daily reporting.
Thank you, Joe. So the daily reporting is really a snapshot, is what I like to refer it to. The software application is very robust and in-depth. A lot of times as a supervisor, manager, or utility engineer of a system, you just don't have time to dive into that deep level of it. So what we really looked at is we wanted a high-level overview, and how it works is the report comes in per email to me every single morning. I can open this report, look at this snapshot of the pressure zones. I don't have to log in. It's a custom daily report, very high level, but key stats by zone. So I can see very quickly everything looks good, or we do have an issue that we need to address. So I can get the data I need and go about my day very fast. I'm going to turn it back over to Joseph French.
So one of the first findings we found was the impact of tank fill operations. We saw a pressure drop during tank fills and then a subsequent pressure rise after the tank was full. To mitigate this, we adjusted PRVs to smooth out the pressure trends. This helps avoid bursts and stress on the pipes. Bottom line is we see issues where we couldn't before, and we can get out and resolve them. Another finding was a low pressure area where a customer had called in complaining of low pressures in the mornings. We were able to validate the customer complaint with the pressure profile by taking a look at the data. This was in a specific area of town that had historically underperformed our hydraulic model. It's something we had knew about, but were unable to determine the total impacted area and the cause of the issue. Doing a little bit more investigation, we were able to work with some of the customers, and our cemetery being one of them, we were able to work to readjust their irrigation times. And another thing we were able to do was make adjustments to a pressure sustaining valve and keep the levels above 45 psi. So kind of a combination of things, we were able to mitigate the issue and stop the pressures from dropping so low.
All right, so we do have a poll question that we'd like to ask our audience here, and that is, which of these pressure issues do you encounter the most in your system? And there's 5 different options here: pressure too high, pressure too low, swings in pressure, pressure transients, and maybe it doesn't apply or you're not sure. All right, looks like we're going to cut it off there. So we have a mix of responses here. One of the more common ones is pressure too low. Certainly I could understand that. If you have pressures that are dropping below critical thresholds, that could impact water quality, and there could be regulatory consequences to it. So definitely something you want to address with pressure monitoring. On some of the other points there, pressure too high or swings in pressure, Walla has encountered some of those, and I think Joe French is going to talk about some examples of that. So with that, let's turn it back over to Joe French and walk through a couple more examples.
Thank you. So like Joe said, not only do we see low pressure issues, but we saw some high pressures as well, as this slide shows. You can see on the graph we had quite a spike in pressure. With the pressure profile, we were able to speed up our reaction time. So we've seen in multiple areas high pressure. Could be related to an open boundary valve, or in this situation, it was a PRV that was stuck open. So we were able to diagnose the issue, notice it in the pressure profile. We were able to see it within hours as opposed to days. We didn't have to wait for a customer call to identify the issue.
All right, and we have another poll question for our audience members, and that is, how do you typically find out about a pressure issue in the system? So the options are customer complaint, SCADA system notification, field check with a gauge, that could be a manual gauge, battery-powered sensor or logger, and then finally does not apply. So we'll give everyone a few minutes to get that response in. All right, so we have a winner. Looks like customer complaint is the most common response there. And I think that really highlights one of the benefits of the pressure monitoring solution, and that is enhanced customer service. You know, Joe French was talking about some examples where he's able to work with the customers to help manage some issues, but also to be able to alert customers to problems, you know, before they find out on their own, and even proactively mitigate issues that you're seeing in the system. So I'm going to turn it over to Adrian to walk you through Walla Walla's approach to pressure management and some of the work they've done on that subject matter so far.
So one of the key points we were using pressure management for in this pressure profile is really to reduce our non-revenue water through decreased pressure. We've done the math and calculated out about 0.8 gallons per service connection per day per PSI. So we're really aiming to reduce our pressure where we can to save real losses. It's an effective tool. It also extends asset life, keeping those pressures just not over-pressurizing for any reason, unnecessary high pressure. So we're really looking at, through over the winter months, to even drop our pressures more and save those losses. You do have to be very careful with pressure management to keep your minimum pressure levels maintained. It's a great platform for that. We can tell hourly if we are maintaining those, or if we have a dip or we're headed down too low, and we can make adjustments. Very important for water quality and fire flows to keep your pressures up also. Daily, in the past, daily average of pressure, or 1 point, or just points at your well houses or pump stations, it's really not enough data to diagnose. You get an idea, but typically it was go put loggers out for a couple days, then come back, get your data, try to figure out what's going on. With this real-time data coming in, it's very fast to diagnose an issue and get a truck rolling to resolve it. As I mentioned before, we're really looking to reduce our pressure in the winter. We're going to start in zone 4, our very bottom zone, and we're going to drop the PRV set points in that zone to see what kind of reduction in non-revenue water we can do throughout the winter months, non-irrigation season. In the future, and it's actually this week, I'm pretty excited, we're using another application of the Ally meter for a prototype to automate dual pilot controls on a PRV. So we could actually go from winter settings to summer settings with the push of a button in the office. So that's a pretty exciting other application that we're working on right now. So kind of the adventures in zone 4, this is where we started, and we weren't 100%, or at least I wasn't, of what this pressure profile was going to show us and how powerful it was. So in the first part of that graph, you see a lot of peaks and valleys of pressure coming up and coming down. And what we found out is we had PRVs fighting with each other, and they weren't set to work in conjunction with each other. That causes a ton of stress on the pipe, and our assets are already failing. So we really wanted to smooth that out, and it's just a great example of being able to see what is actually going on in the system. So the wear and the tear on the assets was really a big one for me. We fix a ton of leaks every single year, and if there's any way we can reduce that, I'm always looking for that. The next big thing you see there is that big spike downwards. That was a failure of a PRV in a closed position. This is where I get kind of excited with the call-out part of it. And in another instance, we had a quick response time. Our on-call staff knew, hey, I got a pressure problem. This is the area it's happened in, and we had a truck rolling that night prior to even a customer calling in. So really exciting instead of somebody just running out there and not knowing what they're getting into or what's going on. It's, this is the issue and we're going to get it resolved. The last part of this graph you see is where we've actually set it down to winter settings and readjusted those PRVs to work together, and you can see the stabilization and pressure, and that really extends the life of our assets and protects us from pipe bursts and such. So going a little beyond, moving on from the FlexNet metering system where we started, we got the system up, running metering, maintaining it, everything's working good. The pressure profile, getting into pressure management, we started looking at other applications that we could utilize using this existing platform to create not only a smart water system, but now start creating a smart city or smart utilities. The first place we looked towards was level monitoring. Right through the middle of the city of Walla Walla, we have Mill Creek. It is channelized, as you can see in the picture there, through town. Mill Creek is prone to flooding with high rain events or snow melt, the spring runoff. We also wanted to look at blockages. We have a lot of bridges throughout town, so blockages of debris and logs or ice dams that could make this much worse. So we wanted to look at a monitoring solution that could be deployed anywhere for essentially emergency. Some of the hardware we used was the MJK 1100 series level sensors, and then we wired them to a smart gateway which comes into the FlexNet and the regional network interface. Installation, we put the level sensors in stainless steel enclosures that we built to protect them, and these were mounted at a bridge. So a couple examples of what we did here. We have the upstream and the downstream on the center abutment of the bridge. The gateway on the last picture is mounted up near the pedestrian rail. All of this doesn't require any power. It's all ran off of the smart gateway. And it's battery operated in our own AMI network. So this is how the hardware was installed, kind of how it works. I'm going to turn it over to Joe French now. He's going to walk you through the setup in the RNI side of how you get it set up for parameters and what your alerts and alarms you're looking for.
Thanks, Adrian. So now that the sensors are installed, we can start collecting the data and set alerts, kind of tell us what we want to know about what's happening to the creek. So in the RNI, we can set alerts and thresholds of our level here. We wanted to set it a little bit lower just as a test. We set the initial threshold alert at 5 feet or greater, and alerts were sent out or can be sent out via email or text, and they can always be adjusted over the air if needed. This is kind of an example of this is how the info will be displayed in the RNI. We have a graph and also a table view. The snapshots of the report below are sent via email daily. This is similar to the reports that we looked at earlier with pressure. Pass this back to Adrian now. We can talk about a high rainfall event that we had recently.
Thank you, Joe. So this was actually quite interesting. We thought we were going to have to wait for our spring runoff to actually get a good event to where we could see how the whole system works throughout. Joe had set this up with just at a 5-foot realm to alarm out so we could test that side of it. So we have this large rain event. You can see the differential in the graph of the upstream and downstream being blue and green there. Upstream and downstream levels do rise fast. and the upstream exceeds the downstream level. It's a little bit in how the channel's built too, where you see just a small separation between the two. The differential in what we were really looking for with upstream and downstream, and we're still working with Sensus on, is that blockage in that dam. If you started getting a partial blockage or blockage, we're going to start to see that differential separate in two different levels of water. We were hoping that's where emergency personnel would be dispatched to go out there and say, we believe this bridge is partially compromised or blocked. So in the right-hand corner, you see a small text message. This is what we got when it alarmed out at 5 feet. We got a text saying we have exceeded our parameters. Also, an email was sent. So what we're really hoping for is reduce our response time in the middle of the night when your personnel are waiting for a possible flood event. Before it breaches, they're going to get called out to say, hey, we've hit this limit and it's go time. So the other application that we've deployed with the pressure profile and pressure management system in place already was the remote shutoffs. The Ally meter has this built in, and it's a great feature. The business case for us, we have a small deployment that we put out currently, but it is very much time-saving and money-saving for truck rolls. The cost of an Ally for us has returned about 2.8 years with our $15 per shutoff figure. This is based on, like I said, a very small deployment of Ally meters. Other utilities might have a greater benefit for this if you have long travel times or many more shutoffs you're trying to do on a weekly or monthly basis. So other utilities, other than Walla, might find a much greater benefit for the remote shutoffs. Our installation locations were based more on pressure management than the frequent flyer customers. Better for instances, we used it for dogs in yards that have always been a problem. We have potential disgruntled customers that we don't want to send staff into that yard. Cars parked, this happens to us quite frequently on shutoff day. The old car is parked over the meter box, so we can right now from the office just shut their water off. We don't have to have more trucks roll out there to take care of the issue. So it's a great feature that's, I could see a great benefit for probably large utilities would really utilize it. Some of the methodology and how that works, I'm going to turn it back over to Joseph French.
Thanks, Adrian. So with the middle-of-minute communication mode with in FlexNet, this allows us to have a response time for commands of less than 5 minutes. So we can change the valve state pretty quickly over the air. There are a couple of valve states that Joe Dreyer mentioned earlier. There's a full shutoff or a trickle mode. We actually installed an Ally meter at one of our employees' house, and he volunteered to live for a day or two on the reduced mode just to see what it would be like, and he really wasn't very happy. He said he'd fill a glass of water, but that's about it. A shower was definitely not going to happen. Another thing with the Ally, the pressure sensor is on the system side, so if we do shut off the customer or the valve, the monitoring application isn't impacted. It's really a great device, and we're pretty happy with all of its applications right now. I'm going to pass it back to Adrian.
So looking towards the future, we've already done some level monitoring kind of out of the box for water, pressure profile, and we still want to push it forward. There's a couple of more applications that we're already running through their paces, and there's more to come for ideas that we have. This is where it really gets exciting for me that this is just the beginning. We are understanding the capabilities of what we can monitor, what we can control, and so it's really getting outside the water realm box and looking at wastewater and stormwater and other issues. You can see in the pictures here, we have set up a temperature sensor. This is below our effluent of our wastewater treatment plant. This is a really proof of concept for them. They have to try to get down in these rocks in the wintertime, and so we're able to bring in a daily report and send it to them of the temperature below their effluent and how that's impacting the creek. It also logs all that data, so it's a great resource. Another site we went to is one of our industrial plants. There's a dissolved oxygen and pH sensor in the wastewater system right inside of a manhole, and then we just pulled it out, put in a smart gateway, and we can start reading every 15 minutes pH and DO, looking for them to exceed their BOD limit, or if they do like a major cleaning and it's a really high pH, we know that's coming to our wastewater treatment plant before it actually hits it. So we've really pushed this out to other groups within our city to understand the capabilities. We're not experts in every field. We're just trying to utilize this investment of technology that we've made to its full potential. So I'm really excited about the future across really the country and all utilities to see what applications this new technology is going to be used for. With that, I'm going to turn it back over for Joe Dreyer to sum us up.
Thanks, Adrian. So to summarize our discussion so far today, we've provided you with some background on Walla Walla and their transition from regular AMI, if you will, to a smart utility network. They're using the same network that they use for metering to power new applications across the water cycle, including pressure monitoring, level monitoring, remote shutoffs, and even things like temperature, DO, and pH monitoring. They found benefits on the operations side with increased system visibility and response time, and they're better equipped to tackle the most important challenges that they face, including non-revenue water and aging infrastructure. So with that, I'd like to open it up for some questions and maybe a little bit of discussion.
Great. Thank you very much, gentlemen. Yeah, we do have several questions coming in here. Joe, I'm going to stay with you really quick. Just kind of generally speaking, just to kind of sum up here before we get into some other questions, what are generally the best points in the system to monitor pressure?
Yeah, definitely. So, at Sensus, we really believe in an asset-efficient approach, in terms of deploying pressure monitoring sensors. And so what that means is using existing points of access. So, for instance, a meter connection, an existing sampling station, maybe if you're in the southeastern United States, even a backflow preventer. Sometimes those are above grade. Test ports in commercial and industrial meters are a great option. And pretty much what all of these have in common is that they're existing points of access. The installation goes quickly without a lot of capital costs. And then when it comes to designing the monitoring plan, you want to consider, how well you're covering the whole system. And in order to really do that, you have to consider these points that are available to you where you have easy access for pressure monitoring.
Sure. Okay, and then Adrian and Joe at Walla Walla, I'll just go to you really quickly. So, I know you mentioned some of the success you had with the pressure monitoring, and you talked about Zone 4 and how you were able to detect the PRV failure, and you knew exactly where it was. I guess just overall question: how has the pressure monitoring helped you go about sort of achieving your overall pressure management?
Yes, this is Adrian. First and foremost, we're responsible for delivering clean and safe drinking water to our customers. So any decisions that we make on our operations side really need to keep that in the forefront. Practicing good pressure management to reduce real losses, we still need to make sure we don't impact water quality for our customers. So that means maintaining adequate pressure levels in all areas of our distribution system, which you can now see with the pressure profile. Up until we used our AMI system for pressure monitoring, we really didn't know what levels in our system on an ongoing basis. So we couldn't be confident in our approach to pressure management. So the importance is really to have a real-time visibility of the whole system so we can understand it, so we can reduce pressure where we need to for reducing real losses. And the big thing that we really saw was the swings in pressure. So it's really a risk management also for your aging assets underground.
Sure. So how frequently are you capturing pressure readings?
That might be a good one for
Ally.
Joe French.
Yep.
So with our smart gateways, we usually capture pressure readings in 15-minute intervals. I believe with Ally meters, their set default rate is 1 hour sample rate for pressure readings.
Okay. Okay, and again, we just have several questions coming in here from some of our attendees, and so for anyone still on with us, if you have any questions, feel free to just submit them, and we'll go through as many as we can here in the next 5-10 minutes. So, Adrian and Joe, I'm sure you guys might get this without getting too much into cost. I'm assuming that these, the Ally meters or, some of these, they cost a little bit more than traditional meters, but, without getting into specifics, has Walla Walla found this to be a pretty good return on investment?
This is Adrian. Yes, definitely. The Ally meter, the greatest feature about it is you get this very high resolution metering is number one what we're looking for. And then you add temperature to that meter, and then you add pressure to that meter. And now on top of it, we have a remote shutoff, all within the same piece of hardware. So it is a great return. It's used for multiple applications, just one piece of hardware. And it's really just a plug and play into a residential meter setter.
What is your uptime on the meters? Someone here asked that.
I'm not following on that question. I'm sorry.
Okay, well let's just a couple clarifications coming in here. Maybe we can just go through some of these. At the beginning, I know you mentioned a little bit about the system, but how many total water and sewer customers do you guys have?
We have around 11,000.
About 11,000. Okay, so at this point, have all the residential meters been converted to Sensus meters?
Yes.
Okay.
We completed our swap in one project. It took about a year to replace every meter.
Okay.
We already had several in the system, but the majority of it was completed within a year.
Okay. And then just kind of a follow-up to that, someone asked, and this is a big trend across the country with regards to water utilities and kind of customer service initiatives, but are you guys making customer usage data available to customers, to end users?
This is Adrian. At this stage, we are not. There is a good platform out there for the customer portal where they could log in. We have really focused on daily reporting for customer leakage on their side and contacting them immediately. That's where our leak credits have just drastically dropped because we catch them so fast that it's usually only pennies that it's cost them, and then they can get it resolved. It is something we are looking at towards the future. I do believe if you were a tiered rate system, that would be a much greater benefit for a utility to have that customer portal so they could manage their own water usage.
Okay. Okay, another question here on monitoring chlorine residual readings. Are you guys able to do that?
The technology is out there. From what I know, which is pretty limited at this stage, the sensors are somewhat limited. So I think we're waiting for that technology to catch up because that is definitely somewhere we want to go in the future. When a digital chlorine sensor comes out and we can put that anywhere in our system, or that could even be incorporated into another piece of hardware like the Ally, pretty exciting idea there. So I think that's something we're going to see in the future that could really impact the water industry.
Yeah. And then maybe on that end, what about someone here asked a question about in regards to your pressure monitoring now. Are you able to sort of evaluate the effectiveness of water main flushing?
We have not done a complete system-wide flush at this stage with the system in place. So it will be quite interesting to see, looking at the pressure profile and that data coming in as we are doing a flushing. So I think it will probably end up showing us some flaws in our distribution system that, possibly some valves shut off here, too high a velocities there, dropping pressure in other areas. I think we'll be able to finally see that there are some issues in our distribution system that we can get resolved.
Okay. About how many Ally meters have you installed for the remote shutoff?
We've installed about, I think to date, about 77 Ally meters. We have about 20 that were installed just for frequent flyers and issues.
Okay. Question here about sort of the data storage end of things. How or where are you storing the data that you're getting from this system?
So I can answer that. This is Joe Dreyer from Sensus. So all of this data, it goes into the same head-end system, if you will, that they're using for metering. And so we call that the Regional Network Interface, or the RNI. And Adrian, if you want to elaborate on how you guys access that data and how you make use of it from a software standpoint.
Sure. Yeah, there's multiple ways, and that's one slide I kind of got into, whether you're a manager of a water system or you're a person on the application side like Joseph French. There's lots of different ways to utilize that. Looking at these other applications where we get into the wastewater too, you may not want everybody to have access to your RNI. I sure wouldn't. So that's where the daily reports really come in good. It's just importing that custom report out every single morning, so the people that need that data, they have it at their fingertips daily.
Yeah, absolutely. And just maybe as a follow-up to that, we had another attendee here ask about if there were, with how you're managing that data, is there any concerns about, I guess, the system being overloaded from the amount of data coming in from, like, say, multiple meters every 15 minutes?
Yeah, so this is Joe Dreyer. I can help answer that question. So typically when it comes to these pressure monitoring devices, you're looking at an order of magnitude lower than the number of service connections. So let's say, for example, you have 1,000 service connections. You might expect, about 100 pressure sensors or other devices that would be sampling at these faster intervals, because you have to remember that most of the meters in the system are sampling every 4 hours or 1 hour and transmitting that every 4 hours. And so up to this point, they have a really robust FlexNet system. We haven't seen any problems with capacity, but that's certainly something where if it did become an issue, we could certainly address it through the RF design and make sure that the system is handling the volume of data appropriately.
Okay. And I was just curious. I don't know if you guys mentioned it. If you did and I missed it, then I apologize. But I know at the beginning you were talking, Adrian and Joe, about I think in 2004 your non-revenue water you were estimating about 30%. Has there been any improvement on that? Do you guys kind of know where it's at today?
Yeah, it was in 2014, which was kind of in the middle of our really kickoff of leak detection and starting the talks of AMI and getting that project up and viable solution for us. So we've reduced our non-revenue water in the past 7 years by about 550 million gallons. We started off at about 1.2 billion gallons a year, and through leak detection monitoring, we've also reduced our consumption through customer leakage. So it's taken a lot of different fronts, but this is really showing us, and in the future with our pressure zones, being able to monitor them and meter them against our consumption meters is going to really hone in on where our issues are. That way I can put the funds I have annually to the biggest benefit. So we have a pretty significant decrease. We still have a pretty long road to go, and hopefully with this new technology it'll get us that next step down the road.
What do you think is really the immediate next step, and that you guys are looking to achieve here with continuing on this effort? Maybe as just a way to close here.
The next big step for me is to get all of our pressure zones metered so we can split our system into 4 pieces. With the AMI, the FlexNet system, we can create a virtual meter for that entire pressure zone. So we'll have X amount of production meters coming in and 1 consumption meter. So we can start seeing non-revenue water per pressure zone on a daily basis. That'll really be able to tell us, hey, where are our real losses at, where are our problems at, and that way we can dispatch crews for either leak detection or for repair or who knows what, maybe pressure management at that stage also we'd look at it. So our next big step is to get zones metered and then find out where the true issues are and put our money there.
Excellent, very good. Well, I think that's a good place to end, and so with that, we will go ahead and close. Thank you again, gentlemen, for the great presentation. So we do have a couple questions that were still coming in from attendees, but we will have our presenters work to get those answered offline here following the presentation. So for any attendee, if we didn't get to your question, we will be in touch with you following this presentation. So thanks again, everyone, for joining us today, and I'd especially like to thank Sensus, a Xylem brand, for sponsoring this webinar. So Adrian Suter and Joe French at the City of Walla Walla, again, thank you for your participation, and Joe Dreyer over at Sensus. Thank you, Joe, and if anyone would like to refer back to this webinar, we will have it archived on our website, waterfm.com. So if there's anything you missed or would like to refer back to, we will have it archived there. And with that, we'll look forward to having you join us on the next webinar. Take care, everyone.